Short review number 2, we're going to talk about transformations. It says, write the equation of the transformation of y equals absolute value of x. The function is shifted left 3, vertically stretched by a factor of 2, reflected across the x-axis and shifted up 5. All right, so left 3, that means we're going to have inside the bars absolute value of x plus 3. And up 5, we know that that's going to be over here plus 5. Vertically stretched by a factor of 2, we're just going to put a 2 in the front of it, and reflected across the x-axis, that's a flip, so it's going to be negative. So we're talking about transformations. That's all there is to it. Number 2, use your knowledge of transformations to write the equation of the transformation of y equals x squared. Well, we can see there's a flip, so that's going to make it a negative x squared, but let's see what else is going on. The vertex here, let's see where are we at, is shifted over 2 and up 3. The vertex is at 2, 3. So my x squared is going to be x minus 2 squared with a negative in front of it and a plus 3. Only thing left is to see if there's any kind of scale factor. So notice the scale, I'm going down 1 and over 1. I'm going down 1, 2, 3 and over 1. That's going to be your typical 1, 3, 5 pattern. So we don't need to put a stretch factor in there. It's just a scale factor of 1. It is a flip. It is shifted right and up. There's the equation. All right, so transformations. Give the intervals for which the graph is increasing, decreasing, and constant. Also give the domain and range. So I feel like this problem should be easy. However, I know a lot of students miss this. This piece right here is definitely increasing. And so when they want the interval, they're just talking about the domain for that piece, not for the whole graph, but for just that piece. And if you look at the x's for this piece, it looks like it's going from positive 1 to infinity. So it's increasing from 0. It's increasing from 1 to infinity. So where is it decreasing? Well, right here, it looks like it's decreasing. So again, I'm looking at the domain of that piece. I see an open circle here, and so the decreasing, it looks like it's going from negative infinity to negative 2, and this one has a parentheses because the open circle means I don't equal that negative 2. Obviously, this is the part that's constant, and so we're looking at this is going from negative 2 to positive 1, like that. Filled in circle, open circle, tells me this is going to go from negative 2 to positive 1, just like that. Increasing, decreasing, constant, pretty simple question. The domain and the range. Domain is the overall x values. And so we can put it all together. This graph is going to go to here, and then the constant part's going to fill in the circle and take us to here, and then the increasing part's going to fill in the circle and take us to here. It looks like the domain is going to be all real numbers. And then the range looks like the lowest y is down here, and it's going to come up, and yeah, it's just going to go up forever because this is going to go up forever and this is going to go up forever, and I don't really care about this. Put it all together, squeeze it all together. It's covering all of those y values from negative 1 and up. So the range is going to be from negative 1 to infinity. So we've got increasing, decreasing, constant, we've got domain, we've got range. Those should be quick ones. Yes, if possible, give the inverse. You're going to have to calculate an inverse. So if you remember, The steps for this were, let's call this y. Just take it out of function notation. Switch x and y. Isolate y. Last step, we're going to have to do the square root. Oh, you know what's weird about this one? This graph I know is a parabola. X squared is a parabola. And I should have thought about this, but when it said if possible, that's a strong hint that sometimes it's not possible. Okay. And you probably forgot about this, but how you can tell it's not possible here is it doesn't pass the horizontal line test. A function has to be one-to-one. This one is not one-to-one. And so there's no inverse. The inverse does not exist. And I guess what tipped me off here was when I'm getting ready to have to take the square root here, it's technically this plus or minus square root. And so you're not going to have two different pieces, the plus or minus. That's kind of what told me that it wasn't going to work. So this is not one-to-one. F inverse does not exist. So that's not very interesting. I think part B is maybe more interesting because it actually does exist. An x to the fifth graph kind of reminds me of an x to the third graph, I guess. This one is going to exist. So let's go through these steps here. Call this y. Switch x and y. Oops, that's a 5. We're going to isolate y, so subtract the 7 over here, x minus 7. Divide by 2. Y to the fifth. And then to solve this, we're going to do the fifth root. Don't need to do the plus or minus, that's only on an even power. We're just going to do the fifth root. Y equals the fifth root of x minus 7 over 2. Last step, just change it back into the function notation. We were talking about f of x, so f inverse of x equals the fifth root x minus 7 over 2. Just like that. Number 5, expand a logarithm. So this is kind of weird, but you might see this on the final. And this third root throws people for a loop here. We didn't do a whole lot of examples, but this is totally something that you could see on the final. Wink, wink. So it might help you if you change it out of the radical notation and put it into exponential notation. So think of it as log base 5 of 2 times a to the 1/3 over b. And if you can get it into that form, maybe it looks more like something that we've talked about more. All right. So if we're trying to expand this, we know that this times is plus, and we know that divide is minus. So we're expanding it. It's actually going to expand into 3 different logarithms. We're going to have log base 5 of 2. And since it's times, it's going to be plus. And then you're going to have to take this exponent and move it around to the front. That's the tricky part, I suppose. So we can say that's 1/3 log base 5 of a. And then divide, so we're going to subtract log base 5 of b. I don't think expanding it into 3 logs is very useful. I think it's a lot more useful to us to go the other direction. So imagine if I gave you this problem and said condense it into a single log, and we took those 3 logs and changed it into that. Make sure you're ready to go either direction, either expand it or condense it using those properties.